Now I'm going to give you a trick question, but have a go anyway. So here, calculate the area from calculate the area of this from -1 to +1. So it's me asking you to evaluate this. Okay, from -1 to 1, and so it's really me asking you to find out this area here. Okay, so have a go anyway. It's kind of a trick question, but have a go anyway. Press pause and have a go. Okay, when you evaluate this, you're trying to integrate this. You integrating that would be you. Oops, sorry, would be you looking for something. You looking for something in such a way that when you differentiate it, it will give you this. Well, visualize this here as currently it's x to the power of -2. So you're looking for something that when you differentiate it, it will give you x to the power of -2. Well, try -1. Okay, when you differentiate this, it will give you -1x, and then to the power, well, blah blah blah. We've done this many times. So it's really you adjusting this, blah blah blah. We've done this many times. So when you integrate this, it will give you negative x to the power -1. Well, it will give you -1 over x. Okay, we've done this many times. So integrate this, it will give you this thing here. So you integrating this, it will give you this. Okay, so you evaluating this, it will give you this. And now you've got to put this into here. So that will then give you this, and then take away. So it's really now it's this, take away this. So when you put -1 into here, it will be -1 here, and then this thing here is -1, and then this whole thing here is +1. Now you've got -1, take away 1, that will give you -2. You see the area is -2. Well, if you look at the graph, how can the area be a minus area? Because if you look at this here, this must be some sort of positive area. If anything, it should be a positive area. But here we've got a negative. You see, me asking you to calculate from the area from me asking you to calculate the area from -1 to 1. Well, when it comes to this graph, 1 over x squared here, you can't really do it because there's a break in between. Well, there's a break at x equals 0. There's a gap in between x equals 0. In order for you to calculate the area, it has to be contained. It has to be somehow be contained, the whole thing. Here you've got a gap in between, so you can't really do it. It's like me asking you to calculate this area here. Suppose you have this function here. I don't know what, something like this. Okay, and then you've got something like this here. How would you calculate the area from A to, let's say, B here? You see, there's a gap. Me asking you to calculate this area here, you can't really do it because there's a gap. You can't really do it. You need it to be sealed. So hang on. You need it to somehow contain the whole thing. This here, you can do it because everything's contained within here. But then if you have a gap somewhere in between, then you can't really calculate the area from A to B here. You can't really calculate the area. Okay. In the future, we will leave this to another time. We will leave this to another time because in a way this is continuous. In a way, it's kind of continuous because you're moving along here, and then we will leave this scenario for another time. Okay, but as far as we're concerned, for the time being, a function needs to be contained or needs to be sealed up in a way. It needs to be sealed up. It cannot have some sort of a break, a break in the middle here. This here we cannot calculate the area of, or we can't calculate the area of this because there's a gap in between. But in the future, we will leave this to another time here. Okay, we will leave this to another time. But for the time being, if there's a gap, if there's some sort of gap in between, you can't really calculate this area here. Okay.